Hello, my name is Michael and I want to talk about the question, should we measure snow surface temperature? We did a comparison between regular thermometers and infrared measurements. This is a regular measurement setup. You take a thermometer, which you are placing on the snow surface, and you are placing that in the shade, for example, of such a shovel, because if direct sunlight, for example here in the sun exposed areas, would hit these metal pieces here, they would tremendously increase the values and you would get wrong measurements. This is our measurement setup, so we took additionally an infrared camera on a tripod and made a video out of this from this shading process. What you see in the next slide is such a video. First I had no shovel, then I placed the shovel, and you can see how the cooling process is starting in this shaded area. So this is the thermal view on the snow. What you can see here is the temperature of the non-shaded snow surface. You can see some disturbances here by the metal pieces of these thermometers. When I play the video now, you will see that I will place the shovel, the shade will be there, and the cooling process will start. You can see that this is approximately, what you can see is approximately in real time. So here the shading starts, and the cooling process is quite obvious. What you're creating here is something new, a new artificial snow surface temperature, which is quite a bit different to what is actually surrounding. To make that a bit more scientifically, we have chosen a pixel here in the sun, under direct sunlight, and a pixel in the shade, and have studied how that develops now in time. This is showed here in this graph. You have time here, and you have temperature here. You have in red the pixel under direct sunlight and the shaded one here. So what is quite obvious is that when the shading is starting, that there's a fast decrease in temperature, a cooling process starts, and that you get quite different values between the shaded and the surrounding snow surface temperature, which is here about 5 degrees. This is interesting because you are asking yourself what you want to measure. Do you want to measure this temperature or this temperature? And there are reasons maybe for both. So if you want to compare it to the measurements you have done further down in the snowpack, let me say 30 centimeters down, you are more interested in what is actually on the surface. However, you cannot measure that so easily. As I said, you have problems with direct sunlight on these metal pieces. You're probably not interested in that if you compare it to 30 centimeters down, because this is something artificially, but you're doing this because you want to repeat the measurement maybe somewhere else where you can also do the shading process, and you have probably half an hour later a different cloudiness, more clouds, less direct sunlight. And to make that more repeatable, you are maybe interested in this temperature. And you can repeat it maybe also at the next day and compare these measurements then. So what we are doing is looking what these kind of measurements are looking like. And what you can see here at the first time when there was no shading is the reason why we are shading at all. The direct sunlight hitting the metal pieces, and this is causing to have much too high values here. When the shading now starts, we also see that there's a decrease in temperature, not as fast. These measurements are quite a bit slow, so you must wait a bit, but approximately after 10 minutes you get some constant values. However, what you can see, these measurements are in the shade, so they should measure something like that. But it's quite a bit warmer, also about at approximately 5 degrees too warm, which is caused by the diffuse sunlight which is still hitting these thermometers and causing these big differences in temperature. What you can see, however, is that these measurements are quite the same as the surrounding measurements in the sun. So you could say, perfect, this, when I want to measure that, I just put my thermometers in the shade and I will get the temperature in the sun. But as you can see soon in my next slides, this is just a coincidence. These measurements here would be the solution. You can measure maybe a similar these as the infrared camera. However, we have just a bit of problems which we cannot explain yet. Some time steps where the differences are quite large, and we have no explanation to those, so we cannot recommend them at this time. So now we are going to a different day where it's not completely clear, as in this day. It's a day with quite a bit of clouds, we say broken, and what you see with this blue line is again the infrared camera. First sun exposed and then in the shade. The difference is not as much as in the example before. This is why because we have more diffuse sunlight coming from the clouds, which makes the differences between completely sun exposed and shaded not as big. What are doing the regular thermometers in this time? When there's direct sunlight coming on it, we are knowing it's too much too high. But when we are shading, we are this time far away from the shaded and also far away from the sun exposed temperature. And this is because of the huge amount of diffuse sunlight which comes from the clouds. And here again the infrared pistol, which are sometimes quite well, but we cannot explain these values. We have no reason in mind to say when a measurement is good or when a measurement is bad. So to conclude, the question, is a surface temperature with a contact thermometer meaningful? And we can say temperature is overestimated even when shaded. And this makes the measurements quite hard to interpret. The comparison between days are difficult because sometimes you have diffuse radiation because of the clouds, and sometimes the cooling process is quite high, which you are doing here. So you are not really knowing what you are measuring. You cannot compare it to something which is 30 meters down, and you can also not compare what you measure with these regular thermometers. You can also not compare it to a different day or a different place. But we can also not point you to an alternative. For example, this handheld infrared measurements. We are working on an explanation for these bad values, and maybe we can come up with a suggestion next year. These are the sponsors, and we would like to thank them for supporting our work, and thank you for your attention.